So, having co-authored the Continuous Delivery book with Dave Farley, and then I actually have another book coming out this week, the DevOps Handbook with Gene Kim, John Willis, Patrick Dubois. And it's been amazing, really, that it's actually been a successful movement. I mean, we thought this was quite a boring corner of technology, deployment automation, build automation, that's kind of a bit dull, really. And then this whole movement kicked off about how this was actually really important. So that was a huge surprise to me. Very gratifying, obviously, and it's everywhere now. You can't escape it. And so last year, I was kind of looking around, working out what I wanted to do with my life, and this organization called 18F kicked off. So 18F is actually a consultancy inside the US federal government. It's part of an organization called the GSA, the General Services Administration, which runs all the public buildings in America and does acquisition services. So anytime the federal government buys anything from tanks to printer paper, it's the Federal Acquisition Service that buys it. And our third service is the Technology Transformation Service, which is a consultancy which other federal agencies can hire to do lean, agile, DevOps consulting for them. So this is a very new organization. It's only 2 years old, and it was inspired a lot by what the UK's Government Digital Service had done. And I thought, well, this is fascinating. It's a chance to actually do the things that I'm really passionate about, but in a domain which is hugely important, the domain of providing services to the public, which often are the most crusty and awful, despite the fact that they're essential and you have no choice in the fact you have to use them. And the other thing for me was, I've been talking about continuous delivery and DevOps for a long time, and people say, well, that's great, but it can't work in my organization because we're special. And of course, everyone's special. So, you can't just take what's worked in someone else's organization and transplant it into yours and expect it to work, because organizations are complex systems, and that just, it doesn't work. So this is fascinating to me because I thought, well, if we can make this work in the US federal government, we can make it work anywhere. And anytime someone comes up with that excuse, I can say, well, actually, we can make this work in the US federal government. So assuming you're not as regulated as them, you'll be fine too. So that was my hope. Oh my gosh, how my wishes have come true. It's extremely hairy, and I'm going to talk about a lot of the hairiness in this talk, and hopefully it will blow your mind as much as it's blown mine. It's really extraordinary. Please do click on the app and give me your feedback. You can ask questions on the app as well. I'll be happy to answer questions at the end. So I'm going to start by talking about continuous delivery. What's continuous delivery? Fundamentally, it's about making releases a low-risk, ideally boring process. What should be exciting is what happens when you release the software, not the actual act of releasing it. And that's really where the whole continuous delivery movement came from, is a bunch of us build monkeys sitting in a room having a miserable time thinking, wouldn't it be great if you could just release at the push of a button and we could all be out of a job? We wanted to put ourselves out of a job. We want release to be something that we didn't have to all go in at the weekend and sit in data centers. And really my favorite metric for continuous delivery is how many person hours do you have to work to put out a release that's not normal business hours? So hands up if, in order to push a release out for your organization, you have to work some number of hours outside of normal business hours. Okay, many of you. That is a sign that something is wrong. Deployment should be an activity that you can perform in a push-button way during normal business hours, and it has no impact. And if that's not the case, that means you have a problem with your architecture. It's an architectural problem, and often a process problem, and sometimes a cultural problem as well. But it's a problem. It means there's something that you need to fix. So we want to be able to get changes out quickly, safely, in a sustainable way. Any kinds of changes, from firewall changes to data schema changes to code changes to documentation changes. And in the course of actually doing continuous delivery, what's happened is a movement of people have sprung up, originally from the world of kind of big web services in the US. A cross-functional community of practices emerged who all had to solve this wicked problem of building, evolving, and operating these enormous distributed systems at huge scale, both securely and at a rate of change that had never been achieved before. So you had all these companies like Amazon and Google and so forth building these enormous distributed systems that they wanted to be able to change multiple times a day. And now Amazon is at a stage where they're changing, tens of thousands of times a day. They're pushing changes out to production. So the DevOps movement is a community of people who had to solve this problem, and now we find this everywhere. So, we want to do the same thing in the US federal government. We want to be able to ship it. Often, it looks a bit like this in the US federal government. It shouldn't be rocket science to launch software, but often it is. And the analogy with rocket science is interesting because when you're launching space missions, you have a checklist, and before you actually do the launch, you've got to check off all the different tasks, make sure all the different systems are working, make sure all the different preconditions are in place. And so hopefully when you're about to push out a release, you have some kind of checklist as well. So in the US government, we have a checklist that we go through before we launch new information systems. Information systems is what we call software services in US government parlance. So what does our checklist look like? Well, there's a law around records management, there's a records schedule, we have the Privacy Act, the ironically named Paperwork Reduction Act, Section 508, obviously, we've got acquisition regulations. Anti-deficiency is very important. Government departments are not allowed to run out of money before the end of the year and then be like, oh, we ran out of money, and now you have to give us more money. They got wise to that pretty quickly. You've got the Economy Act, the E-Government Act. I don't actually know what the Computer Matching Act is. And so, you can go on and on and on. There's, my boss, Noah Kunin, who I took these slides from, he has actually got an enormous binder with just all of this stuff printed out in it. FIPS is law, so these two things are laws that are written by NIST, the National Institute of Science and Technology, that we have to follow. This is particularly bad 142. That's the one that covers crypto modules, where crypto modules have to be assessed by NIST in order to prove that they actually work properly. That's a real nightmare. And then the behemoth is Special Publication 853, which I'm going to show you some slides from later. That's a 400 and something page list of all the controls you have to implement for a federal information system. And not listed here is Special Publication 853A, which is an even bigger publication, about 480 pages, which tells you how to prepare the assessment reports to show that you have actually fulfilled the controls in 853. 860, 1, 2... that's not all, by the way. We also have, 818, 137, which is continuous monitoring. We can go on and on through this. Einstein, which is the Department of Homeland Security system to make sure that nothing gets broken into. Very clever. FedRAMP, and OMB. So OMB is basically the Presidential Office and Management Budget. It's a part of the President's Office that basically makes all the rules about the policies that we have to follow. So they have lots of memos that we have to follow as well. Trusted internet connection, I'm not even going to start on that. So, how many pages do you think this is? Any guesses? 10,000. It's not that bad. 4,006 pages. So that's our launch checklist in the federal government. 4,006 pages worth of regulations. And that doesn't take into account, by the way, agency policies. So there's also reams and reams of agency policies specific to your agencies that you have to follow in order to push something live. 853, I briefly talked about security and privacy controls for federal information systems and organizations. This is law. There was a law called FISMA that was passed, I think, 2001, 2003, Federal Information Security Management Act, which is a law around managing federal information systems. And 853 is part of the documentation that was put in place as part of the implementation of FISMA, which lists the security and privacy controls that every federal information system has to have in place. And there are literally hundreds of controls. So the smallest possible listing of the controls that I could find is 7 pages. And And these controls are pretty complex, and the interpretation of the controls is even more complex. This is actually a picture of my boss's relatives. And he chose this to put this caption on because it demonstrates quite effectively the Talmudic level of interpretation that you have to be able to put in place in order to actually understand how to interpret these regulations correctly. And what you end up with is huge groups of people like this whose job is interpreting these laws and regulations, and they're experts in understanding how to interpret these regulations and how to write the documents that you have to put in place that show that you've complied with the regulations. So every time you put a federal information system live, you have to have an SSP, a system security plan, which shows that you have in fact implemented all the relevant controls and how you've implemented those controls. Then you have to do a security assessment report, which shows how you've tested those controls. And then, since you typically don't actually implement all the controls before you go live, you also have a thing called a POAM, a plan of action and milestones, which lists how you're going to implement the controls that you haven't got around to implementing yet. So it's and these documents, these huge documents, are put in place. It's a public-private partnership. So there's people in government, particularly in NIST, whose job is to create these, but they do it in partnership with a bunch of contractors. And often the agencies end up hiring the same contractors to help them make sure they've implemented them correctly. So it's kind of interesting system in that respect. You get contractors who are like, well, you talk about continuous delivery, it's so hard to do that in a government context. And I'm like, well, okay, fair enough. I get into government, I find it's those people who help write the controls in the first place. They're complaining about how hard it is to implement it. Well, you shouldn't have written them then. So this is the smallest possible listing I could find of all the controls. They're divided up into 17 easy-to-remember categories. From configuration management, incident response, identification, authentication, contingency planning, and so forth. So this is, the first 3 pages, and there's more, and there's more. But that's just the top-level controls. Each one of those controls has sub-controls. So AC2, account management, has sub-controls for automated system account management, removal of temporary or emergency controls, disabling inactive accounts, inactivity logouts, and so forth. So for each one of these, if it's in scope for your system, and again, FISMA divides systems up into 3 types, based on whether they're low impact, moderate impact, or high impact. So you'd see for a low impact system, you just have to implement the base account management control. For a moderate impact system, you have to implement these things in brackets. These are called enhancements. So you have to implement these enhancements. And for a high system, you have to implement these extra things. And there's a whole bunch of stuff here that they just put in, but you don't have to actually implement it. They just thought, well, in the interest of being complete, we're going to list all these things. But don't worry about that. So it's possible to see how you could actually implement some of these things using continuous delivery. So, here's a listing of one of the controls. This is the actual text in 853, which tells you what the control is about. So this one is configuration change control. I can't actually read it on my screen because the text is too small because I fit it on one page. But this is about how you actually implement configuration change control. And it's possible to see how you could implement this using a deployment pipeline, because it doesn't tell you how to implement it. Again, there's a whole army of people who know how this has been implemented in the past, and so they can tell you how it's been implemented, and they can check to see if you've done it in the right way. But there's no reason why you can't do this in a continuous delivery way. The problem is not that you can't do this using modern methods. The problem is that the army of people whose job it is to prepare the documentation and do the interpretation have never done it that way. And so you have to work with them to convince them that it's possible to do this in this completely different way you've never seen before for all of these controls. And that is the huge, gargantuan task. There's also, a whole set of controls, frankly, where continuous delivery is of no use whatsoever. So, for example, media marking. This is a control which means that you have to write on your media, on your disk drives, flash drives, compact disks, diskettes, magnetic tapes, external removable hard drives, flash drives, and digital video disks, the information that's stored on them and whether that information is confidential and so forth. Continuous delivery isn't going to help you with that. But honestly, if you're still using digital video discs, continuous delivery is the least of your worries. It's not going to help you with water damage protection either. This is a control that makes sure that you have some way of providing master shutoff or isolation valves that are accessible, working properly, and known to key personnel in your information systems. Continuous delivery isn't going to help you with that either. In fact, continuous delivery of water to your equipment might actually not be a great thing. So, this is what we're dealing with. It's nuts. And if you're talking about continuous delivery, making multiple releases a day, getting an early prototype out a few months in, you might wonder, how long is it going to take us to get through the documentation in order to put our system live in the first place? And that would be a very good question to ask, because typically, for any new system you're building in the US federal government, your constraint is how long it's going to take you to write the documents that you need in order to get what's called the authority to operate, which you need in order to run the thing. So it takes approximately 6 to 14 months from my system is ready to go live to I can actually put my system live to members of the public. 6 to 14 months, typically. So, John Allspaw likes to talk about, high-tempo, high-consequence environments. Federal government basically is low-tempo, high-consequence environment because it just takes so long to get anything done. And this is especially problematic because we've moved from a world where we care about mean time between failures, how can we prevent things going wrong by being very careful about what we do, to a world where what we care about actually is time to restore service. We live in a world where we now have to accept that failure is inevitable. Any complex system is going to fail. People are going to hack in to your systems. And if your system hasn't been hacked into, that either means it was in fact hacked into and you didn't know about it, or your system basically had no value and no one thought it was worth hacking into. So, if those two things aren't the case, then your system's going to be hacked. And the question is not, how can we make sure that that never happens? It's how quickly can we detect and restore service. When a CVE comes out, for example, when one of the many periodic SSH vulnerabilities appears, how quickly can we patch those libraries? And there are controls that deal with this, but they're a very small minority of the controls, and they're not the focus of this, and that's a problem. Because we do need to make that the focus. We do need to make it, we need to change. I guess what I'm trying to say is, part of the problem is actually implementing the controls is hard, and documenting it is hard. The other part of the problem is the controls were designed for a world that no longer exists, where we didn't have to worry about this so much, and where the technology and process wasn't in place for us to be able to quickly push out changes in order to react. But that's the world we live in, and the compliance architecture hasn't really caught up. That's not a problem we're going to solve soon. But what we can solve to some extent is the problem of working within this regulated system. So coming back to the DevOps problem, in terms of these controls, some of them we care about from a dev perspective. Most of these controls are actually to do with how we operate the system. So the operational environment is a huge amount of those controls, and the process around operating the system. And it's kind of unfortunate because the way that the federal government traditionally has worked is that everything's been contracted out. And typically you contract out the development of the system to a different group from the people who are going to operate the system. And the developers have to implement all the controls, or many of the controls, and in order to prepare all the documentation, you need to start talking to the ops people from early on. And this is not something that is very easy to do, frankly. And the team at 18F was thinking about, well, how do we resolve this problem? And I think the biggest breakthrough we had is that actually we can solve a lot of these problems by putting in place infrastructure as a service, platform as a service, because what you can do is you can take care of a lot of these controls at the infrastructure layer. There's a whole family of controls to do with the physical environment, things like fire protection, water protection, and stuff around your data centers. That can all be taken care of at the IaaS level. And so what you find is Amazon has actually gone through the process of getting an authority to operate for Amazon Web Services. Azure has done the same. There's actually a whole bunch of infrastructure platforms that have gone through what's called FedRAMP, which is the process for getting authority to operate federal government systems. So there's actually a whole bunch of infrastructure services that you can just use, and they've taken care of a bunch of controls at that level. Our thinking at 18F was, well, let's extend that, and let's take care of a whole set of controls at the platform layer. And so this is what we've been able to do. We've actually built a system, or in the process of building a system, called CloudGov. And this is an entirely open source platform as a service. Everything we build at 18F is public domain. So you can go to GitHub, github.com/18F, and you can see all the stuff we've built, and it's all public domain. You can go and use it right now. And in fact, you can take Cloud.gov. So Cloud.gov is an entirely open source platform as a service built on open technologies like Cloud Foundry and Riemann and Grafana and a bunch of other stuff. And you can actually, if you go to CG minus provision, you can actually provision your own instance of Cloud.gov. So everything required to stand up an instance of Cloud.gov is open source. You can go to github.com/18f/cg provision, check that out, and then stand up your own instance of Cloud.gov in AWS. So this is currently going through the process to get an ATO, and that is taking months. But once we've gone through that process, we can take care of many of those hundreds of controls at the platform layer. So you can deploy to cloud.gov and only have to worry about 40 or so of the controls. That makes it much, much faster to be able to build something and take it live if you reuse the platform that we've built. And we're selling this to other government agencies so they can host their stuff on cloud.gov. The other thing we've done is built a system to automatically generate the documentation for you. So all of these documents are typically Word documents and PDFs. All of this stuff is published as PDFs, so you can go download 853 as a PDF. But the documentation you produce in order to put your system live typically is in Word documents, and it's also not publicly accessible. There's a kind of level of information called controlled unclassified information, and all the system security plans, system assessment reports, the POAM, all this documentation you have to produce to go live is controlled unclassified information, which means that you don't show it to people. Because showing people how your system is implemented potentially is a security risk, right? Because if people can understand how your system is architected, they could break into it and hack you. So we've done something which actually proved to be hugely controversial, which was to publish our system security plan on the internet. And if you go to compliance.cloud.gov, this is not actually up to date. We're going to update it once we've gone live, but you can actually see our system security plan and how we've implemented all these controls. And that was hugely controversial. We had to fight a bunch of people in order to be able to make that live. But that means that other teams can now see what good compliance documentation looks like. And furthermore, this is generated from YAML. So the idea is you can describe your system's architecture and control implementation in YAML in a machine-readable format, and then this is a system called Compliance Masonry. So there's a repo called OpenControl, or an organization on GitHub called OpenControl, and 18F is part of a consortium, an open consortium called the OpenControl Consortium, who's putting together ways to produce documentation from machine-readable format in an open way. And the idea is here, well, we can produce detailed compliance documents from YAML just using a program. Revolutionary. And then other people can reuse it. And so you won't have to have these armies of people producing this stuff anymore, because most of it will be implemented at the platform layer, and the rest of the stuff you can do in YAML and create your own reports just programmatically. And then the next step beyond that is the ability to go and actually test those things. So, behavior-driven development, why can't we go and actually run tests to test if these controls are implemented? So write tests, write automated tests to test whether these controls are actually implemented. So that's the next step after this, is to take this stuff and actually be able to run tests and show a list of greens showing that these controls were actually implemented. So this is the journey that we're on right now. We're still going through the FedRAMP process to get cloud.gov actually the authority to operate in production. But once that's in place, it's going to be much, much easier to be able to deploy new services to production. And it has a bunch of other advantages as well. So the fact that you have a platform for production systems, and the fact that you can access that for the systems you're building, you have now a production-like environment that you can deploy to from day one. And if you can deploy into that cloud.gov instance that's non-production, you can have a high level of confidence that your software is also going to work in a production-like environment as well. So no longer are we building stuff in test systems that don't resemble production environments. Well, no. I mean, our cloud.gov instance is the same instance whether you're deploying to production or whether you're deploying to staging. So you can go and deploy your applications to production cloud.gov, but just have it be a staging environment. And the only restriction on it is that you're not allowed to use real information. So the moment you're using real actual information, then you have to have an authority to operate. So as long as you're using dummy information, you can just go and use cloud.gov without an ATO and actually be testing your software in a production-like environment from day one. The thing which is both a good and a bad thing is that we're forcing people into the platform. So obviously, there's a lot of agencies who are running these huge legacy systems in mainframes and whatever, and they would love to lift and shift into the cloud environment. You can't do that if you're deploying to a platform. You have to re-architect. And this is obviously, I mean, who's using a platform as a service right now? Okay, not that many of you, actually, a few of you. This is the problem. You have to architect for the platform. And there's obviously a trade-off to that. My experience is that many of the patterns that are imposed by the platform are actually good practice for distributed systems anyway. Things like 12-factor patterns that Heroku put out, making sure that your logging is external and so forth. A lot of these patterns are actually what you have to do to make sure that your distributed system is resilient in any case. So people complain about having to fit into the platform, and then they build systems that don't fit into the platform where they're actually not resilient to failures of the underlying infrastructure. Like, these patterns are there for a reason, and it's because you're building a distributed system on infrastructure that's fundamentally unreliable. And you have to own that. That becomes an architectural problem that you have to solve either in your software that you build that is resilient to failure of any node or the network. Network partitions are inevitable in distributed systems. You either do that, or you put it on a platform where the platform forces you into a box. And that can be a trade-off that you could be on one end or the other end, except in the context of the federal government, where, guess what? If you're not going to deploy to the platform, here's the extra 100-something controls that you're going to have to write the documentation for yourself. So in a federal government context, that pushes you massively in the direction of preferring to be on the platform and taking the architectural hit, because otherwise, your critical path is going to be preparing the documentation pack in order to put your system live. Infrastructure as a service only takes care of a small proportion of those controls that you have to implement. The platform takes care of a much larger set of controls. It does give you push-button deployments. You can just push a button and deploy straight into production. And as I say, most of the controls are taken care of at the platform layer. And then finally, the other cool thing is making sure that you have templates for all your compliance documentation. We will give you a bunch of templates that you can use, and then you can just run compliance masonry, and it will produce all those reports that you need to produce just by default out of compliance masonry that you can then go and get your stuff shipped. So our goal with all this is to be able to take that process that takes 6 to 14 months and get it down to weeks where it is at present for 18F systems, and ultimately we want to be able to go through that process in days. So from months to days is what we're aiming for. And we're some of the way there, and we hope by certainly next year when cloud.gov is ATO, that we actually will be in a position where we can do ATOs in days. So the message of this is, you can do this in federal government. We're doing it in federal government. And if you can do this in federal government, you can do it anywhere. Continuous delivery in DevOps are hard. It's really hard to do. But the benefits are enormous. And all you've got to do is keep chipping away at the problem. These problems are being solved. And whatever domain you're working in, however regulated, there is a way to do it. You just have to think creatively and chip away at it. And I really hope that the software we're producing is of use to you. Obviously, all the stuff we produce is public domain. Go and check it out, and we really value your feedback. So please contribute code or issues, or please reuse our code. Let us know how it goes. Thank you very much. And we have time for some questions, I think.
Thanks, Jez. That was lovely. So I have two questions that I think are basically the same question. So I'm going to read them both out, and you tell me what you think. So given a lot of the legislation you need to comply with was written and implemented in a time when modern technology systems and development practices were not foreseen, is there any effort or intent to change the law to provide more flexible and responsive controls that can adapt to technical innovation rather than constrain it? And the second question, which is, I think is just a shorter version than the first, is there any effort to change the regulatory environment such that the next team doesn't have to go through what you've had to?
The law is very slow to change. And the other problem is, I mean, the way the US system works is you end up with these enormous bills because the bills don't have to be all about one thing. What ends up happening very commonly in US government is you have a bill about one thing, and then people stuff loads of other unrelated things into that bill. And then it has to go from the House to the Senate, and then often back to the House. And so it's a very risky process. You never know what you're going to end up with. And then, typically, the law doesn't talk about the implementation. Then someone like NIST goes away and determines what the implementation looks like. So it's a very blunt instrument. And I don't think realistically that the law is going to change significantly anytime soon. However, that still gives us a bunch of flexibility. So we have, as I kind of showed you earlier, these controls we have to implement, and we classify federal information systems based on three axes: the confidentiality of the information in them, the availability of the system, and integrity of the system, which you can shorten to a three-letter acronym: CIA, confidentiality, integrity, availability. And so for each of these, it's low, medium, or high. And the problem is that the low baseline is actually a lot of stuff. You can see that there's, more controls selected than non-selected. It's about, I think about 50-50. I haven't counted it. Sorry. And the problem is that low baseline is a lot of stuff. And I think a lot of what 18F is trying to do is just take government data and make it publicly available. So that government data is often public anyway, you just can't get it. One of the projects we've been doing in 18F is building an API for the Federal Election Commission's data. So Federal Election Commission has an enormous database full of every contribution to every campaign, but you can't get it. You have to submit a request and then they send you it. And what we've done at 18F is built an API. So you can now go to an API and download all the information on campaign contributions just through an API, which is the way it should be. So that data is public data. There is zero confidentiality to that data. And availability, well, it would be a bummer if it wasn't available, but, no one's going to, no government business is going to stop as a result of that data not being available. And again, the integrity of the system, well, that's actually reasonably important. We want to make sure that the data coming through the system is the same data that's in the FEC's database. But actually, in terms of confidentiality, it's not a low baseline, it's a zero baseline. And in terms of availability, again, it's a zero baseline. We don't care if it goes down. So that's not something that's really envisaged here. What is in the regulation is the ability to what's called tailor these controls. So you can say, well, these are the baseline controls, but we can tailor them. We can say, well, for this system, they don't really apply because fundamentally what this is called is the risk management framework. And risk is something that's a business decision. And this is actually in the rules. There's a person called the authorizing official, and the authorizing official issues the authority to operate, and the authorizing official can accept risk. They can say, well, all these controls aren't implemented, but I'm going to accept the risk of that being the case and put it through anyway. So you can do that. The law allows you to do that. The problem is, it's very rare for people to tailor down. People tailor up. They say, well, we're using the low baseline, but we need these additional controls. People don't like to tailor down and take a bunch of controls out. And that's basically because a lot of work in government is that the risk is actually not a business risk, it's, am I going to end up in front of Congress? And that drives a lot of the decision-making process. But it is possible to do that, and I think what we're trying to do in 18F, to some extent, is do these things and have the rain of fire come down on us and continue to live, so that other people can then do it without the rain of fire coming down on them, to prove that these things are doable and that we can survive anyway, and be the vanguard of this, so other people can come behind us and do it with, having seen that it's been done before, basically. And so this is something we have been doing. We've been taking risks. We've been accepting risk for systems that don't fulfill all these controls because we think, actually, these things just don't apply because guess what? It's public data, so there's no confidentiality. So that's the approach we're taking to solving that particular problem.
Okay.
Other questions?
Are there other
we have
questions?
some. We have some more.
Raise your hand, and I will run around the room. Or we could take an early break.
There's one over here.
Ah, there's a hand.
So what kind of magic did you use to convince people that this is a good way of doing things? Like, I have, there's so much pushback in our organization when you came and say, well, I can auto-generate this in 13 seconds that you have been using months and months to do. And there's always a little king has a kingdom and don't want to change things. So what did you do?
What did we do? What we did is a little website called healthcare.gov. Who's heard of healthcare.gov? Have you heard? And the reason you've heard of healthcare.gov is because it was a disaster of epic proportions. This is Obama's signature healthcare legislation, and it was going to be implemented by a website called healthcare.gov, and the website did not work. And what happened was they got a bunch of people from modern technology companies to come in and fix that problem. And what the White House realized as a result of that is, this current way of doing things doesn't work, and it's going to cause our legislation to fail. We had better change the way we do things. So what caused us to be able to do this was a massive crisis of epic proportions that was going to have impact on tens or hundreds of millions of Americans and not enable them to get health care and pull the president down with it. That was what enabled us to do this. That may be hard to replicate at your organization. And this is the unfortunate truth. It often takes an enormous crisis in order to be able to push something like this through. This is the trick at big organizations. Big organizations which are successful, you can't change anything. And there's a good reason for that, which is because people want to keep on doing the things that made them successful. You're like, you shouldn't do this. And they're like, what do you mean? We're enormously successful. Why should we change anything? And you're like, well, yes, right now, but in about 5 years' time, no one cares about 5 years' time. You've got your quarterly shareholder report that you've got to deliver, and that's what you care about. No one's taking a long-term vision of the process. And so, Winston Churchill had this saying, never let a crisis go to waste. And I think, that's the unfortunate reality in a lot of large organizations, is that there has to be some kind of crisis before this happens. And if there's any consultants in the room who know how to make significant transformations within an organization that's not in crisis, please, I want to know your secret. It's really hard to do. And even then, it's been an enormous struggle for us. We also are very lucky to work within the General Services Administration, which, despite the boring bureaucratic title, is actually at the forefront of a lot of this stuff. They were the first. We can use Gmail at the GSA. We can work from home. We're now using Slack. There was a bit of controversy over that, but we are now officially using Slack. GSA, I work from home. GSA is an organization which is distributed. You can work from home. We use Google Apps, we use Slack, we use we all have Macs, and that's because we work for a very forward-looking organization. But again, it's partly the way the organization is structured that allows that to happen. GSA runs the federal buildings. We work in the federal buildings. If there's too many of us working there, it becomes expensive to run them. So in as much as we have a very kind of enlightened teleworking policy, it's partly about the fact that actually it's cheaper for the GSA if people work from home. So a lot of it is about working out where the pain is in your organization, finding the people who the pain is affecting most intensely, and working with those people to try and solve their problems in a way which pushes you in the direction of your vision. That is really the kind of heuristic, I think, for this. If there's a part of your organization which isn't in pain and you're going to completely change the way that they're going to do things, they're going to say no. Why should they? There's no reason for them to change. So find the parts of your organization where there's pain and find ways, this is the conversation we were having just before this talk, which is exactly right, and work with them to solve their problems. Other questions? There's one right at the back there.
Oh, thanks.
Is your exercise for the day done?
You couldn't come this way. Oh, I'm sorry. There we go.
Hi. I actually used to work for the federal government for about 10 years. So I'm a little
Congratulations,
curious.
sir.
Yeah. I'm a little curious about the procurement process. I mean, I know about the procurement process within the federal government. How has the lengthy procurement process impacted your ability to cut your delivery time from 6 months to 14 months, from 14 months down to a more manageable time period to bring your product out the door?
Yeah, so that's a great question. A big part of the problem is procurement, exactly as you say. So one of the things we've done in 18F is we've actually created what's called an Agile BPA. So the BPA is a procurement vehicle, basically. And we basically invented this thing called an Agile BPA, where, the traditional way you go through procurement is, you go to schedule, which is a list of vendors who are approved, and then you send them an RFP, and then it's basically an enormous exchange of documentation. And then at the end of the enormous exchange of documentation, someone goes off for like 5 years and builds something. And then you might or might not get something that's fit for purpose at the end of that process. So what we did instead is the Agile BPA. Companies bidding for those contracts have to submit a working prototype that's built using open source code that we can see. And that's the only way you get in to the bidding process. And so we were kind of surprised, actually. A number of big contractors ended up giving us working prototypes built on open source code for our first service that we put out through the Agile BPA. A lot of them didn't. A lot of them were just like, working codes, crazy talk, and just couldn't do it at all. But we did get a surprising number of people who gave us working code. And then one of the conditions of the Agile BPA is that the code is open source. So they have to work they have to build open source code in a public repo, and we can see what they're building all the time. And at the end of it, the code is obviously open source, it's public domain, anyone can use it. So our rule is basically, if you're going to write code paid for by government dollars, that belongs to the people, because the people have paid for it. So all that stuff will be open source. And so we awarded our first procurement under the Agile BPA last year. Came out recently. If you go to the 18F blog, you can actually see a really nice montage of the images of the website as it evolved from website goes here to an actual working website listing, and it's a website that lists all the systems that have been given a FedRAMP authority to operate. So you can actually go and see all the different cloud-based offerings, SaaS, IaaS, and PaaS, that have been given a FedRAMP ATO on this system that was built using an Agile BPA. You can go and download the code. It's totally open source. So that's our approach to solving that particular problem.
One more quick question from the app then. Or not from the app, from someone using the app, I presume, unless it's that smart already. So, there's loads here, some really good questions. Okay, documentation. Documentation still needs to be reviewed and approved. Okay, so although we can generate it automatically, it needs to be reviewed and approved. I hope and assume, says the question. This still takes a lot of time. How can you make your goal of days instead of weeks, given all of this additional work that needs to happen at the sides?
Yeah, no, that's exactly right. I mean, what is going to end up being the constraint is the review process. So we're just taking from the Agile playbook for this, which is do as much of the review during the development process. So at the end, all you're typically going to be doing is running scans against the production system to look for vulnerabilities. So vulnerability scanning is the big one that you have to do against the real production system rather than the staging production system. But all the other stuff we want to be able to do in process at the same time as the development process happens. And again, a lot of this can be taken care of at the platform layer. So, most of these controls are taken care of at the PaaS and IaaS layer, and they're subject to continuous monitoring. So they're running, continuous in the federal government context is not the same as continuous in the dictionary definition of the term. It's like monthly. But all these things are getting scanned on a monthly basis at the PaaS and IaaS level. And so only those 42 controls are the ones that actually, 40, 50 controls are the ones that actually need to be tested before going live. Most of that can be done in process while the development is going on. Only a very few of those controls have to be tested right at the end once you're in production. That is going to end up being the constraint, which means it takes days rather than hours. But again, you can build that in. So the vulnerability scans, you can make that part of your deployment pipeline. You can make code scans part of your deployment pipeline. You can make demonstrating the configuration management process part of your deployment pipeline. A lot of this can be taken care of just by building deployment pipelines, making sure that you're using infrastructure as code, that you can stand up your production system purely from information stored in version control. And by the way, if you want to download cloud.gov, if you go to github.com/18f/cg for CloudGov -provision, you can download and do this yourself. But, a lot of this is taken care of by actually just following good development processes and doing the validation in processes you're developing.
Fantastic. There was one question about how did you convince government that automated test was a way of validating stuff, but that's going to have to wait for another day. Jez Humble, thanks. That was fantastic.
Thank you.
Jez Humble.
Thank you very much.